So kind of what I'm aiming to show here is simulation inside of NX. We'll go ahead and load in the Hass machine and just give an overview of how it works inside NX, the features of it, and kind of the advantages we see over a third-party application like Vericut. So here I just have the out-of-the-box kind of sample file that Siemens provides. Part file, no machine is loaded in our machine tool navigator. So just double clicking our generic machine, I can retrieve the machine from library, and we'll choose your guys' Hass UMC. And then right away it tries to choose a placement point, and you have a couple options on how you want to place it. You can use the part mount junction, which is looking at the fixture and the part and mount the machine to that. You can do it from machine 0, from your MCS. If you had another machine loaded in here, you could use those old positioning constraints. But in this case, I'll just use the part mount junction, select OK, and our machine gets loaded. So this is your guys' Hass UMC750. Right away, I can go into our machine tool navigator. We can preview some motion. So we have our X, Y, Z, and our table. So the nice thing with loading a simulation kit into NX is kind of the simulation and collision check that you can do while you're programming a part. This way you're not having to pack up, send to Vericut, and make sure you know that your tool is long enough that you're going to clear everything. So one of the nice features is if you were to create a tool in here, you can actually dynamically move the machine as you're changing the parameters of this tool. So I'll load in, say, a holder from our library. And even using our sliders here, we can begin to position and see if we're going to clear the tool axis as we're going into the part and create our tool that way, which is a great advantage, I think. So once you've gone through programmed, simulation inside of it is just grabbing your top level program or maybe another program group if you're just trying to simulate a certain group of operations and just choosing simulate machine from the top. Get rid of that. So you can see we have our G code posted through. So it ran through the post processor and posted our G code for simulation. So this is true G code simulation at this point. If we were a little bit maybe further up in the workflow and we just want to check our collision and stuff, we could switch to toolpath simulate, which is going to look at the actual CL data that NX uses to calculate the toolpath. But in here, I'll use the machine code. Along with our posted code here that we can review, we can also look at our machine positions. We can even manipulate them in here as well. I'll just go ahead and start simulating through here. Maybe fast forward this cavity mill, it's a pretty long program. Yeah, so it works true to just like Vericut. It's built to be competitive to it. The great advantage is that you're inside of NX. You're not having to export out to a third party. You can do collision checks as you're building your tools, and it just kind of eliminates that extra step to export out. And with the way this post-processor and simulation are built, and this is pretty common to all 5-axis machines that we develop, is we deliver them together because the post-processor can look at the simulation kit and use that for a lot of the calculations for rotary movement. So it's an advantage on the post-development side. So our normal kind of practice is to always deliver a simulation kit with 5-axis posts for that reason.